Welcome students. Today I discuss some problem on continuity and differentiability.
We just consider an example. Let fx equals to 5x minus 4 when 0 less than x less or equals to 1 and 4x square minus 3x when x greater than 1. Discuss the continuity and differentiability of fx at x equals to 1. So we at first check whether the function is continuity or not. Due to this, to check continuity at x equals to 1, we calculate left hand limit at x equals to 1, that is limit x tends to 1 minus fx. Actually x tends to 1 minus, this minus indicate that from the definition of function fx which value we consider. Actually x tends to 1 minus, that means that fx take less than 1 value. So from the definition of function less than 1 fx is 5x minus 4, so limit x tends to 1, 5x minus 4, that is equals to 1. Next RHL at x equals to 1, that is limit x tends to 1 plus fx. 1 plus indicate that which value this function take greater than 1. fx greater than 1 value is always considered. So limit x tends to 1, 4x square minus 3x, and we get 1. And some fx at x equals to 1, that is 5x minus 4 at x equals to 1, that is equals to 1. Therefore left hand limit at x equals to 1 equals to right hand limit at x equals to 1 equals to value of the function, that is f of 1, that is equals to 1. Therefore we can say fx is continuous at x equals to a. This is equation 1. Now check differentiability at x equals to 1. Check differentiability at x equals to 1. Due to this reason, we consider left hand derivative at x equals to 1. That is equals to limit h tends to 0 f of 1 minus h minus f1 divided by minus h. F of 1 minus h. Actually from the definition of function, a left hand derivative at x equals to 1 means we consider the value of fx when x less than 1. From the definition of function, we can say for x less than 1, fx equals to 5x minus 4. Therefore, f of 1 minus h, we just calculate f of 1 minus h, that is equals to 5 into 1 minus h minus 4, that is equals to 1 minus h, and f of 1, that is equals to 1. We just put the value of f of 1 minus h and f of 1, ultimately we get plus 5. Next, right hand derivative at x equals to 1. Right hand derivative at x equals to 1, that is equals to limit h tends to 0 f of 1 plus h minus f1 divided by h, that is equals to f of 1 plus h. From the definition of function, right hand derivative means greater than 1. For x greater than 1, fx equals to 4x square minus 3x. F of 1 plus h we just determine, and ultimately we get 1 plus 4h square plus 4h, and we just put the value of f of 1 plus h and get f of 1, that is equals to 1, just put, and we get 5. The left hand derivative at x equals to 1 equals to right hand derivative at x equals to 1. This implies that function is differentiable at x equals to 1. And from 1 and 2 we say that f is continuous and differentiable at x equals to 1. We consider another example. Let fx equals to 1 when x less than 0, fx equals to 1 plus sin x when x greater equals to 0, so that fx is continuous at x equals to 0 but f dash 0 does not exist. How we can solve? See, to check continuity at x equals to 0. তাহলে LHL at x equals to 0. that is limit x tends to 0 minus fx. From the definition of function, we consider fx, value of fx when x less than 0, that is equals to 1. So limit x tends to 0, 1, that is equals to 1. Right hand limit at x equals to 1, limit x tends to 0 plus fx, that is equals to limit x tends to 0 from the definition of function, value of fx when x greater than 0, that is 1 plus sin x. So we here write limit x tends to 0, 1 plus sin x, and if we put x equals to 0, we get 1. And we also evaluate value of the function at x equals to 0, that is equals to 1. And therefore LHL at x equals to 0 equals to RHL at x equals to 0 equals to value of the function, that is fx at x equals to 0, that is equals to 0. Therefore that is equals to 1. Therefore fx is continuous at x equals to 0. To check differentiability at x equals to 0, right hand derivative at x equals to 0, that is r f dash 0, that is equals to limit h tends to 0 f of 0 plus h minus f0 by h. তাহলে for x greater than 0 fx equals to 1 plus sin x, তাহলে f of h that is equals to 1 plus sin h. Also f of 0 that is equals to 1. We just put here f of 0 plus limit h tends to 0 1 plus sin h minus 1 divided by h. 1 deducted, therefore we can get limit h tends to 0 sin h by h, and this is the value 1. Also calculate left hand derivative at x equals to 0, that is L f dash 0, that is equals to limit h tends to 0 f of 0 minus h minus f0 divided by minus h, that is equals to limit h tends to 0 f of minus h minus f of 0 divided by minus h. For x less than 0, fx that is equals to 1, f of minus h that is equals to 1. Therefore 1 minus 1 divided by minus h, that is equals to undefined, 0 by minus h, 0 by 0, undefined. Therefore right hand derivative at x equals to 0 not equals to left hand derivative at x equals to 0. This implies that fx is not differentiable at x equals to 0. This implies that f dash 0 does not exist, and hence the result.
Thank you student. Like this video, subscribe my channel Easy Learning. Bye, take care.